Hey, East High Optics students, what's going on? Eckert here. This is actually take two of videos. Mr. Conroe called me while I was filming the other one, and well, he texted me, and then I called him. And we talked about grades and stuff like that. So just know that even though the content's coming from me, Mr. Conroe is actively behind the scenes, seeing if you guys are doing any work. So today is going to be your first lesson, if you will, of marking period 4. Any work prior to this day counted for marking period 3. Us as teachers, we still don't know how we're going to grade or how they're going to tell us to grade marking period 4. The only thing you have control over is doing work, right? So if we give you work, get it done. Now, with that, every class, they want you to break it down into 2 assignments a week. I'm going to simplify that for you, and just like with last week, you're usually going to get 1 assignment from me a week. What I find is that the work that we give you it's like 72 minutes worth of work, right? So that's an hour, over an hour's worth of work. Break that into half. That's their 2 30-minute lessons that they want, or 30-minute assignments that they want every week, right? So I'm just going to condense it. You're going to have 1, but it's going to be like, think of it as your 2-part assignment for the week. Get it done at some point. It's going to take about an hour, hopefully a little less, and that's all you got to worry about. So getting into lesson for today, we're actually going to talk, and I'm going to share my screen with you, and we're going to talk about the curve generator again. So this is, I like to come back to the curve generator because I know it's something that everyone has done. There's still some people in my class and probably in your classes as well, in which people haven't polished. So it's tough to do some polishing stuff, but the work that we do when we talk about with curve generating lends itself to polishing. So with that, you're going to have 1, 2, 3, 4, 5, 6 lenses, or problem sets, if you will, to work on. Now, each one of these lenses, lens A, lens B, lens C, D, E, and F, you're going to have different parts or different questions that you have to complete for this. There's 3 parts, if you will, for every lens that you're going to have to complete. I'm going to do 1 with you. So technically, you're only going to have 5 to do, right? I'm going to do lens A with you. So whenever you curve generate, there's always those inputs, those manual knobs you have to turn, dials, you have to dial in settings. Remember, and you have your recipe sheet. So we're going to assume for every single one of these lenses that you've set the machine, you've ran it, and then you get results from that, right? So let's look at lens A. Lens A is a 40-millimeter diameter part. Now remember, diameter of a lens. You're talking about the actual width of the optic. So it's a 40-millimeter diameter. We want you to generate, or you have generated or tried to generate, a 206-millimeter convex curve. Convex. Remember, convex, concave. Convex is a bubble. Concave goes inward, like a cave. And you've done that on a 7.26 millimeter blank. Now, when I say 7.26 millimeters, I'm meaning the thickness of the blank, the thickness, how thick it is. You set your tool angle to 4.2 degrees. And your y-axis, so remember, angle is where that tool sits on angle. The more angle you have, the more curve you have. The more curve means a shorter radius. I'll say that one more time. The more angle you have, the more curve you have, and the shorter of radius you have. The y-axis setting is the setting that moves that tool. I'm going to have to use a remote and a vitamin water cap. So let's say that this is your lens and this remote is your tool head. Remember, that tool drops down onto the lens and it carves into it, right? So this is angle. The flatter the angle you have, the flatter the curve. The more angle you have, the more curve you have. But the y-axis moves the tool head in space either forward or backwards, right? Forwards or backwards. So this is like a side view of generating a lens. Remember, for convex, that tool, the front edge of the tool needs to be over the center of the lens. And for concave, the back edge of the tool needs to be over the center of the lens. Subtle difference, but that's how you make a convex versus a concave lens. So this is giving you your y-axis position, 17.45 millimeters south. And I'm going to say, and when you're in the room, you see north and south. So I'm actually going to change this in all of your documents. I'm going to change this to back. All right. So front and back of the machine. So when you're making a nib adjustment, you're either going to come back or forward, right? You then have a z-axis setting. The z-axis, remember, is your height of the tool. And we're not going to have to worry about that. You do not need to adjust the z-axis. You're also going to have a riser start gauge. The riser start gauge tells you how much material you're going to remove. Now follow me on this, and I'm going to go over to a different screen. The riser gauge always stops at 20.0, right? Now this is me drawing on it with a mouse, so I apologize if it's terrible. But how the riser start gauge works is if you set the start gauge, let's say to 18.0, the riser gauge moves up in space until it hits 20 every single time. I want to redo that so you can see my arrow. It moves up in space. So if you start the riser gauge at 18 and it's gone to 20, how many millimeters has it moved? Well, hopefully you guys can do this math. It's moved 2.0 millimeters. So if you've moved 2.0 millimeters, you've removed 2 millimeters worth of material, in essence. To further cement that, remember, this stops at 20, but let's say we generate a lens and we set our riser start gauge to 16. Well, now it's moved up from 16 to 20. You've removed how much material? Oh, Mr. Eckert, I've removed 4 millimeters worth of material, right? So that's going to change your thickness of your part. How much? Well, if you had a part that was 7 millimeters in thickness and you've removed 4 millimeters worth of material, you're going to have a 3 millimeter part, right? Pretty simple to think about. So let's go back to our assignment. Hopefully you understood that one. And now is where we get into the results section. And I might change it a little bit in the document to bold this. I think I will do that right now. Let's italicize it. So we generated a part. We came out with a nib that's 2.2 millimeters. And the swirls say the tool is too far back. I'm going to put back. okay? I might change that. I don't know. But the tool is too far back, so you need to tell me how far we need to move it and in what direction. Obviously, if the tool is too far back, you're gonna move it forward, but by how much? So you're gonna move it 1.1 millimeters. Remember, when you have a nib, you want to cut your nib in half. So half of 2.2 is 1.1. So that 1.1 move is going to happen forward. Here's what you got to tell me. What's your new y-axis position then? So if you're moving the tool forwards and you were backwards, you're going to move this y-axis position by 1.1 millimeter forward. Spoiler, forward means you're adding. Backwards means you're subtracting. Okay? So your y-axis is going to go from 17.45 to, what's 17.45 plus 1.1? 18.55 millimeters. So let's go, so here's how you're going to answer these questions. You're going to go to a new page. You're going to put lens A. You're going to put part 1. I'm going to enter. I'm going to put part 1. I think I'm going to have this spelled out a little bit better for you guys. You're going to tell me the correct y-axis position and dial units needed to correct the nib, right? So this is going to be 18.55, right? 18.55 millimeters, and you're going to move it forward. Okay? That's part 1. Part 2 is where we get a little tricky now. So right now, from that, you should be able to do lens B, C, D, E, and F for part 1. Part 2 is going to get a little trickier. For the lenses below, find the correct tool angle in degrees to the nearest hundredth. Here's how this works. Your tool angle is generating a curve, and the sag is how we measure that curve, right? So the sag difference in microns tells you if your sag is low or high. Obviously, this one right here has a sag difference of -70 microns. What does that mean, Mr. Eckert? If my sag is negative, well, I'm going to go back to this document here. I'm going to open a new page, and I'm going to draw a couple curves for you. I'm going to draw some shapes. So here is my first lens, and I'm going to call this my desired lens. All right. Now I'm going to draw another one, and I'm going to start it in the same spot. Notice how I'm doing that. And I'm going to start to draw it, and I'm going to draw it the same diameter. But the sag on this lens is low. So here's we got 2 lenses that are the exact same right now. But I have a sag of -70. What that is telling me is that the curve is a little too flat. Now I could make this extreme and say, ooh, here's a very flat curve, right? It's hardly any curve. But it's only 70 microns, which is actually not a lot. So the curve, if I were to draw it to like an actual like perspective, would probably be this. And it wouldn't be anything, you know, terrible, but the sag is off by 70 millimeters, low. If it were plus, it would be a little too much curve. And you have the same diameter, but you see as I increase this, you get more and more curve. That would be a positive sag. So, but right now I got a -70 sag. So let's say my sag is here. I have to change the machine to fix that to come up to this point right here. This is my sag difference, and I'll put a little arrow from there to here. No, it's hard to see that arrow, but that's the sag. I'll draw it out here. Here's your sag difference right there, okay? -70. Now there's a rule for this. For every 10 microns of sag difference, every 10 microns of sag difference, you move the gauge 0.1 degree. Let's go back and look at our settings. So my sag difference is -70, meaning for every 10 microns, I move that gauge 0.1 millimeter. Look at my tool angle. I'm sorry, 0.1 degree. My tool angle is 4.2 degrees. I am -70 microns. Let's go back to the picture. Is that curve too flat or too steep? It's too flat, right? We need more curve. Well, back in the beginning of this, what gives us more curve? You should be saying more angle. More angle equals more curve. So I need to increase this angle by how much? If 10 microns is 0.1 degree, 70 microns is 0.7 degrees. So I'm going to increase this angle by 0.7. And you're going to come out with part 2, new setting, 4.9 degrees. Oh, I can spell degrees, right? 4.9 degrees. Part 3. For the lenses below, find the correct riser gauge start position that creates the target thickness. Well, right now, we've ran the machine one time. We've set what's the gauge that determines our thickness. The riser start gauge, right? Riser gauge start. We set that to 17.32, and we have a measured thickness of 6.85. But what do we want? We want 6.5. So we have to increase the amount that that gauge is going to travel up in space. So if my riser start gauge is at 17.32, and I want to remove how much more material? Well, if my measured thickness is 6.85, I'm going to get better at this, I swear. And my target is 6.5. How far away am I? I just got to do a little math right there, right? There's my 5. I get a 3, and I get a 0. I have to change this 0.35 millimeters. But there's a little trick to this gauge. Everything you do with this gauge, you have to multiply by a factor of 2. It's just the way the gauge is. So if I want to remove 0.35 millimeters of material, I have to multiply that by 2. What's 0.35 times 2? Well, you guys had a calculator, you'd be doing it instantly, but 2 times 3 is 6, plus 1 is 7.70. Or on the riser gauge, it's 70 units, right? Because remember, the riser gauge is just a fancy, it's not even fancy, it's just a spherometer put into the machine that sets the gauge. So my target thickness is 6.5. Find the correct riser gauge start position that creates the target thickness. So I want to remove more material. You can't add material onto a lens, so that if you miss it in that regard, you're done for. You got to make a new lens. but my riser start gauge is 17.32 millimeters. I have to change this, lower it by 0.70. So 17.32 was where I was at, and I have to change it by 0.70. And we got a calculator to do the math. Drop my 2 down. I have to borrow this guy. That guy goes to a 6. That is a 6. 16.62 is my answer. I'm going to change the riser start gauge to 16.62. And that, ladies and gentlemen, is the third part. Part 3 equals 16.62 millimeters. So that is how you do this assignment. Now, obviously, it took me a decent amount of time to do one. There's some thinking involved in this. This is problem solving. And this is authentic. This happens all the time when you run a curve generator. You then have to look at the part. You have to measure it. You have to verify your results. And if you have settings that are off, you have to problem solve and tell me how to fix it. You have to do that for lens B, C, D, E, and F. That's your assignment. I'm going to change this around a little bit before I post it and give you an answer spot where you can put your response. It'll be a little nicer. I haven't converted this to a Google Doc yet, so I will do that for you. If you have any questions, remember, I have office hours at 9 a.m. Mondays and Tuesdays. You got to set your alarm if you got questions and join me. If not, if you can't make those times, email me, set up a different time that I can give you some hands-on, not virtual hands-on help. I'm going to call him out. Jonathan Velasquez has been one of my only students that's joined my chats, and I help him through the work. And once we finish the work, we like talk about basketball. So it's not like I'm like, making you do more work than you have to do. It's very lighthearted. I help you out, give you support on the work, and you do it. Now, hopefully these videos are enough, but I understand that not everyone can look at what I just did and understand it off the first time. So it may take some repetition to get it. But I will say that the more you do this, you'll start to understand what it is. So 3 parts for everyone. You got to tell me how to correct a nib. You got to tell me how to correct your tool angle. And you got to tell me how to set the riser gauge for your desired results. All right, guys, that is it for virtual optics. This is, oh God, what week are we in now? We are in week, let's see, this is 14 and 15. So we're in week 7, 8 of this. I'd rather be in the classroom working on machines, but we're not. So here we are. All right, guys, have a good one, and good luck. Stay healthy.